Welcome to this week's edition of Good Books Radio. Audiobooks.com is the chief underwriter for Good Books Radio, which is produced by UTRGV Media Services for Rio Grande Valley Public Radio. And now, here's your host, Dr. John Cook.
Welcome once again to another edition of Good Books Radio. I'm your host, Dr. John Cook, and with me today is Dr. Jana Grcevich. She has worked as an astronomer and a science educator at the American Museum of Natural History and hosts at the Hayden Planetarium. She received her undergraduate degrees in astronomy, physics, and mathematics at the University of Wisconsin-Madison and her doctorate in astronomy at Columbia University. She teaches astronomy to future high school earth science teachers as part of the Master of Arts in Teaching program at the American Museum of Natural History. That impressive resume that she has reflects the fact that she has written a great book that she co-authored with Olivia Koski, and the book is The Vacation Guide to the Solar System. It's a mix of science and fantasy that's a really delightful read. Dr. Grcevich, welcome to the program.
Thanks for having me.
It's a wonderful read for a guy like me who grew up aspiring to be an astronaut when the Mercury and Gemini and Apollo flights were on TV and all schools stopped to watch what was going on in our exploration of space. And I want to get into the details of that, and usually I start at the beginning, and I do want to talk about the challenges one faces in space travel, but I wanted to note that in the acknowledgments, you mentioned so many people that helped you make this book possible, and NASA is among them. But you mentioned the Guerilla Science group that your co-author is head of operations for. And what does Guerilla Science do that helps push the envelope a little bit?
Yeah, it's a group that runs really innovative science-related events to spark curiosity and wonder. And so that's actually how we got started with this project was we ran a space travel agency called the Intergalactic Travel Bureau through Guerilla Science.
Mm-hmm. And you know, it was just recently that the president and his daughter were talking to Peggy Whitson for setting a new record for being in outer space. But I wonder how much bone density she'll have when she gets back. That's one of the risks.
Yeah, there's a lot of, and your body changes a lot when you spend time in space. And so, you know, in researching all of these amazing things that can happen to your body, it makes you realize how difficult it is to keep humans alive in space, especially for the extended periods of time that would be required to visit some of these further flung locations.
Well, we want to talk about those inhospitable climates a little bit because it goes well beyond fantasy with some of the things you suggest in your travel guide, like sandboarding and rappelling and rock climbing, especially with the moons around gas giants. But let's just start with preparing for your trip because it doesn't motivate me to want to go there considering how difficult it is to get ready.
Well, you know, I think that some people are drawn to the challenge, right? I think something that's really compelling about space travel is that it's not easy, and you really do need to prepare your body and continue, you know, keeping it in good condition throughout, you know, any sort of travel in space. And it's not an easy thing, and, you know, it's kind of interesting to kind of put it in the frame of a vacation because that makes it seem like, you know, you're just this relaxing, easy thing, and that's not space travel at all. But I think that contrast between how difficult it is in reality and the idea of a vacation is kind of something we wanted to explore in the book.
Mm-hmm. Well, mentioning some of the physical attributes you need, like vision and blood pressure and height, some of that was surprising to me.
Yeah, one of my favorites is the fat face and chicken leg syndrome. So your body is used to pushing the blood against that constant force of gravity that you have on Earth. And so when you go into an environment where you're no longer exposed to that, sometimes the body has a little bit of trouble adjusting. And so you get skinnier legs, kind of chicken legs, and your face might kind of swell up a little bit, get a little bit fatter. You can also experience some nasal congestion and things like that. And so, yeah, it really changes the body.
Mm-hmm. And some of the training is recommended, like military water survival and the pressure test and gravity training, looks rather rigorous for someone my age, for sure.
Well, it's just mixed, right? So we're going off of the standards that are required of NASA astronauts traditionally, and so as time goes on, and especially for things like suborbital flights, I'm sure some of these will be relaxed. But we did want to stress that it is hard on the body and that training is required.
Mm-hmm. Okay, so let's talk about some of the things that you should consider packing. Velcro and duct tape, for instance.
Mm-hmm, yep. I was really intrigued by the fact that, there were some issues with the moon buggy, and they used duct tape to fix it. So, it's useful in space as well as here on Earth to fix it all. And Velcro, of course, because you need a place to kind of secure things, right? You're used to just being able to set things down on a surface, but you don't have that luxury when you're experiencing microgravity, and so things like Velcro are really useful for keeping things straight and making sure things aren't floating around, because that can be actually quite dangerous if it gets somewhere that it doesn't belong.
And when we start looking to adapt to our luxuries on Earth, one of the things you mentioned when you say pack soap is you won't bathe very often.
Well, that's the thing. You're going to need to bring all of the water that you need. At least, we do think a little bit about how we could gather water from other locations you might visit, but for the most part, you're going to be bringing everything along. And so things like showers, I don't even know how you would shower in microgravity, but you kind of have to do more of like a sponge bath sort of thing. If you want to get yourself clean, and so it can be. It's not exactly luxury travel. You're going to have to adjust your hygiene routines quite a bit.
Mm-hmm. You want to talk about how we recycle water to supply enough water on these trips, because that's another area.
There's been a lot of work into how to reuse all the water, right? And that includes water that astronauts have already. They've ingested, and it comes out as urine, and so it really is quite important for that problem to be solved. How to make that into usable water again, drinkable water again, especially for longer trips. If we go to Mars, we're going to need to deal with that because it's just far too expensive and technologically too difficult to send all of the water that you would need that you could just if you weren't reusing it.
Mm-hmm. And the spacesuit for a hostile environment has to have what?
Yeah, it has to protect you in multiple ways, right? It has to, if you're going out into open space, it needs to protect you with pressure. So your body needs to be kept in a pressurized environment. You need to have breathable air, obviously. It needs to have temperature controls. There's a myriad of environmental factors that you need to take into account. It's really like its own spaceship, right? Your own personal suit is like a spaceship that's keeping you alive in open space. And of course, if you're traveling to other places, you'll need spacesuits that are adapted to those conditions as well. You'll have to bring a wardrobe.
Yeah, okay. And as far as gravity is concerned, we're going to be dealing with high gravity, low gravity, microgravity, artificial gravity. How does that affect the body?
Yeah, so if you might, if you're on launch, you feel yourself being kind of pushed back against your seat, right? And then there's that beautiful moment when you're kind of experiencing microgravity for the first time. But depending on where you might travel in the solar system, and again, as we get more speculative, going to like the outer solar system and things like that, you experience like a wide variety of different gravities. And so if you go someplace like the moon, you're going to be experiencing about 1/6 of Earth's gravity. Mars is about 1/3. And so, it's much better, I think, than microgravity for long periods of time, even to have a little bit of downward gravity. But you go other places, like in the upper atmosphere of Jupiter, you might experience higher than Earth gravity. If you were in an airship, for example, it'd be hard to construct an airship that could stay afloat in a really light atmosphere they have on Jupiter. But I love the idea of visiting on an airship and kind of just like relaxing into that higher gravity environment and feeling it push down on you and like really realizing how alien this place you are really is.
The other issue with gravity, of course, is the G-forces when you launch.
Yes.
And how does that impact?
Yeah, I mean, it's people launch safely, but it can affect people, right? It can make people sick. It can, if you experience very high G-forces, it can cause you to black out. So you'll kind of gray out. You'll lose your sense of hearing. And there's certain things that you can do. There's like anti-G straining maneuver that you can read about. It's hard to describe in words. We tried to do it a little bit in the book. But basically there's kind of like tensioning your muscles, and breathing in a certain way can help you prevent passing out when you otherwise have a lot of difficulty with that. And so it's kind of fun. Maybe you can like practice up on that before you go on your trip.
Space sickness is a common problem.
Yep. So, and this is, especially dangerous, right? Because you don't want to be vomiting in microgravity. It's not a great place to kind of contain that sort of thing. But, many astronauts have had issues with that. They design special bags to deal with that situation when it arises. And so, just like keep your head back, they say, don't move around a lot, and that can help ameliorate some of that nausea that comes.
More of why I wasn't sure that I would ever want to travel to far planets is about health. Food and nutrition, frankly, tastes are muted because of gravity-induced nasal congestion that interferes with your sense of smell. It's like eating with a cold, and that just doesn't sound appealing to me.
Yeah, I mean, and this is the challenge, right? Is creating a menu that it's actually, it's not trivial to keep part of making a diet that's going to work for astronauts is making something that they're really going to want to eat and is palatable and enjoyable and yet still meets those technical requirements. So there's a lot of work being done on that, how to make food more appealing. They talked about 3D printing pizzas for space travel. They have projects thinking about travel to Mars and the menus that they might provide there. And obviously cooking in a traditional sense is very, very difficult in microgravity. But on Mars, you might be able to do something like have an induction stove. You definitely don't want open flame because that's a fire hazard. But also microwaves aren't really used because they can interfere with communications. And so they have talked about, induction stoves on Mars. People have thought about these ideas and tried to see what cuisine might be like on other worlds.
Mm-hmm. And, of course, you mentioned you might look forward to eating insects because they're an efficient source of protein.
Yeah. I actually, I've been vegetarian for many years, but I ate insects. I have no problem eating insects ethically, and they're quite tasty. So, crickets kind of have like a nutty flavor. And, there are people that work on breeding insects for human consumption. And in terms of protein, if you want to, grow new food sources on the way, insects might be the way to go.
Okay, great. Okay, let's go on with a couple of other difficulties of space travel. One of them is that going to the bathroom in space takes a little practice.
It does, yeah. The way it's done right now is they do have a toilet. It doesn't look a lot like the toilet that you have in your bathroom. It's got a much smaller hole. Needs to be cleaned out periodically. You don't have plumbing, obviously, to deal with things. And in the future, NASA's looking at a lot of different ways to kind of improve that system, and especially in the spacesuits themselves, if there's a way to deal with that. But it can be a messy business, and so it requires a little bit of practice.
Not to dissuade any people who want to look at this vacation guide as a possible adventure in the future, but let's talk just briefly about radiation and space brain and anxiety and depression. there are some risks to the exposure to radiation, right?
There are, yeah, and I don't think that they're fully understood. I mean, most of the astronauts that we've sent to space have been relatively nearby, in orbit around the Earth, and so they're partially protected by the Earth's magnetic field from the radiation that would be present in more far-flung locations in space. And so, they've done experiments with mice to try and examine the effects of radiation, and there is some evidence that it can have very negative effects on the brain. And so, in terms of whether that's going to be something that will become a problem for humans in, interplanetary travel, is something that really is an open question, but something of great concern to people who are interested in thinking about it. And then in addition to that, there are some locations, for example, the vicinity of Jupiter has very high radiation levels. So if we were to develop technologies that would allow us to get there in reasonable time frame and keep humans alive on the way, they definitely need to be highly protected from that radiation with shielding. Having thick metal is not maybe the best solution for space travel because it's so heavy and so it's so expensive to get that up there. But they do talk about lining spacecraft with water because that can absorb some of the incident radiation that comes in and provide some protection that way. Of course, you need to have water present anyways in tanks on your ships. And so there's people are thinking about how to mitigate any potential negative effects from radiation, but it's an open question and it's of great concern.
Well, let's look at a few of the destinations. Let's start with the one that's most realistic because we know we've been there, and that's the moon. There are an awful lot of moons in the solar system, but this is the one called the moon for a reason, right?
Yep.
Buzz Aldrin said, nothing prepared me for the starkness of the terrain. It was barren and rolling, and the horizon was much closer than I was used to. Interesting view, I guess, from the moon to look back at the Earth.
Yeah. What I would like to do if I could go to the moon would be to look up and see the Earth, right? Now, the Earth would go through phases. You'd see a crescent Earth, a full Earth, over the course of a month. And so I think it'd be really beautiful to go and, see these traditional scenes we associate with the moon in the sky. And this is something that, we talk about even with kids when we're planning space vacations, they've all seen the moon in the sky, right? And so we ask them to imagine standing on the moon and looking back towards the Earth, and they get really excited about that. But also, we always say when you check into your hotel on the moon, you should ask for an Earth view room because the moon is tidally locked, so one side of the moon is always facing the Earth. We never see that far side of the moon. Its rotation is slowed to the point where that just doesn't happen ever. And so what that means is that if you were standing on the moon, the Earth would remain mostly stationary in the sky in the same place. And so you could ask for an Earth view room, and if the Earth was ever in your window, your hotel room window, it would stay there. You could see it go through the phases, but it wouldn't move through the sky the way that the moon moves through Earth's sky.
To look up at the sky brings up the idea of the near side and the far side of the moon and the moon's regular cycle of daylight and darkness. The sun is really bright during the day, and the sky is black, but you won't see many stars because of the sunlight, right?
Yeah. So it's kind of like this very, very high contrast situation, right? Here, everything is kind of smoothed out. The light is scattered by our atmosphere. And so it kind of bounces light in different ways, whereas the sunlight on the moon is much harsher and much brighter. The shadows are dark, and you just don't have those normal effects. You also wouldn't, if you could see stars, you wouldn't see them twinkle because that's the effect of the Earth's atmosphere. Turbulence in the Earth's atmosphere is bouncing that light around, and it makes the stars twinkle, and so you wouldn't be able to see that from the moon. But of course you don't have the light pollution that you'd have here on Earth, and so if you could see the stars, they'd be very beautiful. So on the night side, for example, you have an incredible view.
Mm-hmm. I think there's a lot of interesting stuff in this chapter about, how you could play in less gravity and the problems with moon dust. But I want to move on to some of the other planets. I'm looking at the inhospitable planets like Mercury and Venus, and I was really surprised to learn that Venus is actually hotter on the surface than Mercury because the greenhouse gases keep the heat in, right?
Mm-hmm. That surprises a lot of people, right? But the how hot a planet is really also dependent on its atmosphere. It has a huge effect. And so even though Mercury is much closer to the sun than Venus is, the trapping of the heat from that really thick carbon dioxide atmosphere, it has this crazy greenhouse effect going on the surface. And so it's actually hotter. It's 800 degrees Fahrenheit. You could melt tin on the surface of Venus. And so it's an extremely inhospitable place.
The one planet that
Venus, though. I don't want to go Venus short, though, because this is actually something that surprised me the most in researching the book was that people have, there have been speculative studies done on how humans would survive in the upper atmosphere of Venus. And the temperatures there are very similar to Earth. The pressure is similar to Earth's surface pressure. And so there are challenges like sulfuric acid clouds are very corrosive, but you could imagine sending humans to explore the upper atmosphere of Venus, and it would be much more pleasant from the surface and within the realm of imaginable technological and engineering ability. And another really cool fact is that Earth's atmosphere, if you created a bubble of Earth's atmosphere, in the thick atmosphere of Venus, it could float. It would be buoyant. And so you could imagine floating cities there, which is something that really captured my imagination.
Yeah. In fact, floating cities are probably a good idea on other worlds as well, because you can't land on the surface of a gas giant like Jupiter or Uranus, but you might have floating cities.
You have no choice there. You have no choice, but it is, it would be a very difficult challenge because the atmospheres of those worlds are very light, and so of course you have to have some sort of gas that's in your bubble that's lighter than the surrounding atmosphere, and so it's a challenge. But people have thought about how you might create airships that could travel through the atmospheres of the gas giants.
We have all romanticized Mars, and of late there's even talk of trying to colonize Mars by 2030. So it's a little less inhospitable, but it still has a lot of challenges. But you describe in the opening paragraph butterscotch skies, colossal canyons, and the tallest volcano in the solar system being some of the things you might want to see when you visit Mars.
Mm-hmm. Yeah, it has some incredible landscapes. For example, there's a canyon called Valles Marineris. It's basically the width of the United States. It's huge across the surface of Mars, just this big gash. And it's 4 times deeper than the Grand Canyon. And so, it would just be amazing to go and stand on the rim of that canyon and maybe fly over it. It'd be difficult to fly with so little atmosphere, but, you could rocket over it and it'd be a lot of fun. Mm-hmm.
And the idea of a glacial getaway is one of the things you mentioned in the vacation guide for Mars. The polar caps are interesting in particular.
Yeah. So, there's carbon dioxide, like dry as water ice, in the polar caps, and so you could visit and hike around, and it'd be a very different view than the one you'd have on most of the surface of Mars, which is red and rocky.
Mm-hmm. But we will have those issues of there not being enough water and there not being enough air, and low temperatures can freeze you in a minute, and so there will be challenges that you have to.
Absolutely, yeah. It's sometimes people have obviously need a spacesuit to survive. The pressure is far too low for humans to survive. It doesn't have a breathable atmosphere. The temperatures are very cold. It's an extremely frigid desert. We do know there is water on Mars, but it's not easily accessible. It's kind of in the surface, or it's transient on the surface, and it might also be contaminated with things that are, not drinkable. And so we'll need to do a lot of work to try and figure out if we can access those resources efficiently enough or if we're just going to have to bring all the water we need along with us and just make sure we reuse that very efficiently on a trip to Mars. But in terms of colonization by 2030, I think that's a far too optimistic estimate. I think, that's kind of why also we wanted to think about it in terms of a vacation guide because, staying there and actually being able to be self-sustainable without, constantly sending supplies from Earth is a really difficult technological challenge to think about. I mean, we really need to focus first on sending people alive there. But, whenever I get really discouraged about this, I think back to how people viewed air travel 100 years ago and the way we think about that today and how easy it is to travel to the other side of the Earth. And so, I try not to be too skeptical. There might be maybe in 50 years, people regularly traveling to Mars on vacation. So we'll see.
I began Googling facts when I was reading this because I'm a little behind. When I was in elementary school, Jupiter only had 9 moons. And
yeah.
I mean 12 moons and Saturn 9. But, Jupiter has 46 moons. And there's an awful lot of interesting things that have happened through science fiction for us to ponder, like the movie 2001 and 2010, the sequel, about Jupiter's moons and how they do have oceans underneath the ice on a couple of those moons, like Io and Europa.
There's quite a bit of water down there, and so these are just fascinating moons. So one of my favorite is Europa, which has many kilometers, maybe 20 kilometers of ice in a shell all around it, and then underneath that we know that there's a salty water ocean containing many oceans worth of water. And so to think that you could travel there and maybe take a submarine down there, you'd have to drill through thick ice. But once you got there, you could, potentially with a lot of thermal protection, scuba dive, look for life. We don't know what's down there. There could be life living on there. It's, one of the best candidates, I think, in the solar system for potentially finding life. And it's just a fascinating and beautiful world.
One last note, because we're near the end, is that Pluto was a planet when I was a kid, and it got demoted. But there's a reason for that, right? In terms of how they classify planets.
So and we've discovered other I guess worlds, I could say, that are about the same mass as Pluto and have a very similar orbit. And so Pluto's kind of an oddball. Its orbit goes out of all the other planets kind of orbit in the same plane, but Pluto's orbit sticks out. It has a very elliptical orbit, and very importantly, it also shares its orbit with a lot of other icy things. Most of them are just kind of irregularly shaped, basically comets that haven't made it to the inner solar system. They're just kind of hanging out in the outer solar system. But also things that are large enough, like Pluto, massive enough to form themselves into spheres. And so those other dwarf planets, once you start discovering them, you kind of have to add them to the planet club or kick Pluto out. But, it's just a label. And we really wanted to include, we have a full chapter on Pluto, like the other planets and Earth's moon, because it's a fascinating world. And we knew so little about it before the New Horizons probe took these fantastic images of its surface. And so before, it was just, a blurry few pixels, and that was what Pluto was. And now, it's this world with this giant heart-shaped plains called Sputnik plains, with these churning nitrogen ice. It has pink mountains with methane snow caps. And so it's completely fascinating and nothing like what anybody expected before we visited. And And also, I love that chapter could never have been written before the New Horizons mission, right? And so I think about planets that maybe seem to have less going on, like Uranus. If you look at it, it just looks like this featureless orb, right? But I suspect a lot of that is just that we haven't had the chance to get a really up-close look since the Voyager missions.
And if you want to spend your life on travel out there, you have to remember it's 4.4 2/3 billion miles. 4 2/3 billion miles away from Earth, so it's quite a ride to get there.
Right. Yeah. It's not. A lot of this is kind of thinking about how humans what they would experience if they could get to those worlds. But getting there is a huge engineering challenge, and one we're not really close to solving right now. But places like Mars, and certainly, obviously, we've already been to the moon. We could think about maybe there being vacationers that are on the surface. Of course, Elon Musk is sending people on a trip around the moon, or at least claiming to. So we'll see what happens with that. I'll be very excited to see what that brings.
Unfortunately, that's all the time we have. We've been talking with Dr. Jana Grcevich. The book is The Vacation Guide to the Solar System. It's a fascinating read, and it sparks the imagination. I recommend it very highly. I'm your host, Dr. John Cook. I remind you, if you don't hear our regularly scheduled broadcasts on our NPR affiliate, you can also catch us on YouTube at Good Books Radio, Strong and Cook. Thanks for listening. Make it a great day.